blown up end mill. Shattered finish. Burned edge on a part that should have been clean. Sometimes it is the tool, but sometimes it's the math. Hey yo, Max here with another video. Let's get into it. Galileo said, "Mathematics is the alphabet with which God has written the universe." Way overkill for our purposes here, but think of how freaking cool you'd be dropping that quote in conversation. You're welcome. Now, for us here in the shop, one could argue that the machine spindle is our universe. And while they may not impress the likes of Galileo, there are some mathematics in play with our machining that can mean the difference between life and death for our tooling, as well as our productivity. Let's crunch the numbers. First one, surface feet per minute, or SFM. This is how fast the cutting edge moves through the material, not how fast the spindle spins, how fast the edge travels. Every material has a sweet spot. Push SFM too high on a tough alloy, and you're burning up tool life before the part's even done. Your tool manufacturer publishes SFM ranges for a reason. That number is step one. Everything else gets built on top of it. Second number, revolutions per minute, or RPM. This is where SFM actually turns into something your machine understands. The formula is simple. RPM equals SFM times 3.82 divided by tool diameter. Put simply, larger tool diameter, same SFM, lower RPM. Smaller tool diameter, same SFM, higher RPM. That's why swapping a half-inch end mill for a quarter-inch and running the same spindle speed is a rookie mistake. Changing the cutter diameter changes the speed of the cutting edge, even when the RPMs remain constant. Last but not least, our third number to consider is chip load. Chip load is how much material each cutting edge removes per revolution. The formula, chip load equals feed rate divided by RPM, multiplied by the number of cutting edges. Chip load too light? You're rubbing and not cutting. Heat is going to kill your tool from the inside out. Chip load too heavy? You're overloading the cutting edge and are going to start breaking stuff. Get your math right, and you should stick the landing every time. Now, that's some Galileo math in action right there. There are tons of online resources that will give you all of these values without doing any of the math yourself. But when you learn the math, how it works together, and how to read the chips coming off of your cut, you can optimize your tool life and your cycle times beyond what you're going to get from an online calculator. At shop.wcchapman.com, we do our best to provide all the manufacturer's speed and feed recommendations right on the product pages to get you started. That will do it for this video. Be sure to like and subscribe, and check us out at shop.wcchapman.com or give us a call at 410-686-6860. See you on the next one.